Hello and welcome to this video where we'll go into CRUD operations hands-on. Here we will create, we will read, we will update, and we will delete. We will create data using the insert statement, and then we will do read with select, and we will do update with update, and delete data with delete. Here in this tutorial here, I will go through using glossary data. We'll create the glossaries and their descriptions using insert with some explanation of programming concepts, database and DuckDB. It should feel a little bit like you're working with some kind of glossary application, which you have in the backend and the database, which you can connect to an API as well. Here, for simplicity, or because we have come this part, we'll work in the database side using DuckDB and SQL. Let's move on directly to Visual Studio Code. Okay, here I am in an empty Visual Studio Code. Here you can see CRUD operations, and we'll start with creating a DuckDB. Or actually, we will create some SQL scripts first. Make dir. Actually, I will put all the SQL scripts in the root here. I don't need to have another folder called SQL. Or we can have make dir SQL and cd into SQL. And inside of SQL folder, I will do touch. What do I need to create? A statement .sql. I will have alter.sql as well. And I will drop.sql. And I will have my CRUD operations, CRUD create.sql to CRUD read.sql. Here, free CRUD update.sql for CRUD delete.sql. Okay, I create all these SQL files. Here you can see if I do ls, these are the SQL scripts that I've created. We will work with all of this in this video. Now we will have a DuckDB database, cd go up, cd ... means going up apparent. Here I will do DuckDB-UI, and I will call this glossary and DuckDB. Okay, this opens up. You can see we get this glossary.duckdb, and I will put this here. I'll actually decrease this a little bit. I'll decrease it a little bit more so that we can properly see our database. Because the idea is that I will create a code in the left here, and then I will copy it into these cells here, and I will run them, and you will see the results. Let's create a new notebook, and this notebook I will call glossary. Okay, glossary, and you can see it's connected to glossary. Okay, starting here, we'll go into the create statement. Okay, let us start with actually creating the schemas. What I will do here is create schema if not exists database. I will create this one, create schema if not exists. Programming, I'll have two schemas. I will have the database schema, and I will have the programming schema. I will save this one, and I will also paste it here, and I will run this one. You see that 0 rows returned, 2 statements run. If I run it again, you can see that it's still running because it's potent, because I have put in this if not exists. It does nothing if it already exists. So if I do desk now, you can see what happens. Let's check out which schemas we have. From information schema.schemata. Okay. Here, these are the schemas that we will have. You can see we have glossary. We have, inside of glossary. The other ones are the systems. We don't need to care about those. In the system, we have this information schema, right, by default, and this PG catalog. It's similar to like in Postgres. DuckDB has taken a lot of inspiration from Postgres, but we only need to care about this for glossaries. We have database, we have main, we have programming, right? Copy this inside here as well. This is what I use to check the schemas. Check schemas. Schemas, remember one schema is corresponding to it's a logical grouping. You can see it as a folder of several tables and views, okay? Now we will do one thing is that when we are creating new glossaries in DuckDB, we need to have a sequence in order to have an auto-incrementing ID, because it doesn't have anything built in that makes a new ID come when you're adding new values, new rows. That is the thing that we will try to mimic. We will create auto-incrementing rows using something called a sequence. Here, sequences. The idea is that I want to put in several glossaries, right, into my tables. Here, create a sequence if not exists, ID SQL sequence, start 1. Okay. I will have this table called SQL, and there I will have ID SQL sequence. I will copy the, and I will create other sequences as well. I'll have one that is called Python sequence. I will have one that is called DuckDB sequence, okay? They all with one. Copy this and create a new here. I'll run this one. And you can see nothing returns, but it worked. And now we'll do similar to before, but now we'll go into from PG catalog. You saw that we had the PG catalog before, .pg sequences. Okay, I put it in here and I'll run this one. And you can see here that we have our sequences. We have ID DuckDB sequence, ID Python sequence, ID SQL sequence. And here you can see that the start value is 1. Here's the min value is 1 of all of them. And you can see here is the maximum value that it can take. Yes, and it increments by 1 by default. Right. That is what you need to know and how you can check them. Now it's time for us to actually create a table. Creating tables for each glossaries. For creating the glossary tables, basically. Here, create table if not exists. I go into the database schema, and inside there I'll create this SQL table, okay? It's a little bit strange namings if you're like, you think like SQL is, it's the SQL scripts, and then we have a database is the actual database, but however we use it as a schema now. This is so that you can practice in, it depends on how you put the names. If you put it here, create this table inside the schema.table, then you should know that this is the schema, this is the table. Yes, I could have named it a little bit differently. I could have called it like db_schema or something, and SQL_table to make it even clearer. But I will keep it like this, that you get to practice a little bit of what we're actually creating, okay? Let's create here. ID is integer, right? The ID is integer and it's default of next val. Next val will create the next value within a sequence. Our sequence is defined that it will increment by 1 all the time, right? ID SQL sequence. This means that whenever we're creating a new row, it will go into an incrementing this sequence, okay? We will get 1, 2, 3, 4, 5, etc. Then we get our ID integer default value, and we can also make it into primary key. To make it into primary key, you just put it here. Primary key means that it's unique and you cannot recreate the same using the same ID. Here we have word. It's uniquely identifying a row. And for simplicity, we use auto-incrementing integers for primary key. We will talk more about how to design different keys like primary key, natural keys, surrogate key, etc. later on when we come into our data modeling journey. That is the next course. This course is for analytics and to learn and navigate around in DuckDB and then SQL. Okay, we'll create the word. We make it into string, and we'll have a description as well. And the description is a string as well, okay? This is the data types. And basically, this is what I want for creating my database SQL tables, but I will copy this 2 times because I will have some more tables here. I will have database or the SQL table, and we'll have database.db table. And here I will use the DuckDB sequence. Okay, and otherwise it's basically the same. Idea is that I will have in our database schema, I will have several. I could have SQL, DuckDB, I could have Postgres, I could have MySQL, MS SQL, etc. And here in programming, I can have Python, I could have a C#, I could have Java, Rust, whatever, right? Here I will change this one to ID Python sequence. Otherwise, everything else is the same. I will copy this, put it here and run it. Yes, we have created this table. If I do desk, we can see that we have a few tables now. We'll have glossary here. You can see there is schema database, and programming, and here database DuckDB, database SQL, programming Python. And you can see here is the column names and the corresponding column types. You can see integer, varchar, integer, varchar. Varchar is basically for string, yes? Okay, now we have created our tables. Note that this is not create in terms of CRUD. CRUD, when we're talking about create, we're actually inserting data. Let's move on to our CRUD here. It's time to insert some data. And to insert some data, it's actually we have seen that before. I will just make a copy into it. I'll copy, because this takes a lot of time to write. I will copy it in and I will explain what I have here. Insert into database.sql, and we'll have a word and a description, and basically here you have query, and here this is the word and this is the description basically. What we do now is that if I copy this one in, add cell here, and I copy this one in, and I run this one, and it has inserted one row. Now you can do from, let's see, from database.sql, and you can run this one, and here you can see we get one automatically, right? Because of our sequence. If I copy in some more data now, let's say I copy these things in, CRUD and range conditions, okay? I copy these ones in, and I will add a new cell here. Oh, actually, that was stupid what I did now. Because I ran it, now I will have 2 of queries. That is an issue. I will actually just delete this one. Let me create a new, actually I will create a new cell here. And I will delete this one. Delete from database.sql where ID equals 2. And I run this one and it has disappeared. What we can see now, if I run this one, you can see it has disappeared. Okay, great. Let's move on now. What I want to do is that I want to copy this code in here. I will create a new cell up here. I copy this code in, insert into database.sql a word, comma description, and I add a few more, right? I run this one and 2 here, and if I run this one, you can see, 1, 3, 4. And why is it 3? Because I accidentally created one before, which here was ID number 2. It's auto-incrementing. The last ID that I created, it was 2. Now it's auto-incremented to 3. And next one is 4, and on a 4th. Okay, this is normal behavior. What you could do, if you want to have the old ID, then you can actually change your sequence. You can make the sequence to go back to another value, but I won't show you that here. Instead, we'll move on now with the insert. We have inserted data into database.sql. Let's insert some data into Python as well. Here is Python. It has value here. We can actually, this is a little bit too little, right? I will add some more. Here we can do comma, and I would copy this one. Let's see what we'll have. I can have type hint, for example, hint or which type in, for example, parameters, return values, okay? In classes and function. Okay, I can copy this one, can create some more, say, let's see, we can take tuple, for example, and here say immutable, works similar to list, also store records. Not just immutable list, that will be wrong. Okay? Or actually, I don't want to auto-format this, it's quite ugly. Okay, here we have for programming, I will copy this one in. I will add a cell here. Paste that one in. And actually here I will change my from database from programming. Because if I just do from Python, you'll see that there will be an error because it's inside of the programming schema, right? I need to do from programming.python. Okay, here you can see this is the data that I've gotten, and you can see the ID has started from 1 because this is another ID, another sequence, right? It's not the same sequence as we used before. And now I will copy one more thing from the, let's see, this is for database.duckdb. Copy this one in. Basically, it's the same idea here. I will create a new cell here, paste that in, run it, and I will do from database.duckdb. Okay? Yes, and you can see here's the DuckDB data, the glossary, right? Okay, that concludes the crate of CRUD. Here we have inserted some values. Now we'll go into the second one. We'll read some values. To read some values, yes, we can do from, if we do select star from programming.python. This is equivalent to doing just from when it comes to DuckDB. Both these will give the same results. If I do select star from, let me run this one. Select star from Python, you can see we get this. It's the same. And the idea is that, okay, if you want to read the other ones, you take just from database.sql and then from database dot, let's see, .duckdb, right? This is same. That is the read, and with the read you can do filtering as well. You don't need to just do select star. You could, for example, do select star from database.duckdb where ID is larger than 7, for example. Then we'll get the last 3. Yeah, exactly. We get the last 3 glossaries that we have created. For example, you can do some filtering in your read as well. And I won't do much filtering here because we have already gone through filtering, but you should know that, okay, the read operation is using the select statement for that, and in DuckDB there's a from, which is a shorthand for select star from. Okay, and then I will go into CRUD update here. Let's go into update. Here I want to update, I want to add a column called learned to my database. In order to do that, we won't go into the update part first. Instead, we'll go into the alter, because now we're actually modifying this table, right? What I want to do is that I want to alter table database.duckdb, and I want to add column learned, and this is a boolean, and we default it to false. Okay. Copy this one. What this does is that we alter means that we will change this table, we modify it, and we add this column called learned, and it will be a Boolean, and it has a default value of false. That is how it works. Okay. I will create a new cell here, and I will do this one. Right now, if we do from database.duckDB, and I run this one, and you can see, word description, ID, word description, and learned is false. Okay, great. Now I want to actually update this to true for those glossary that I have learned, right? That is the idea. And you can also do this for the other ones as well. I will just demo with one that you know how you're doing it. I don't want to take away all the fun from you. Okay, now let's do, we will want to basically check, or we want to do a check mark for glossaries which we have learned. For example, you have a front end where you have a glossaries here, and you do a check here if you have learned it, or you maybe have a test and then you have scored correctly for the glossaries that you know, and then it will give a check mark that you have learned it. Okay, and then this should be reflected in the database. And if you want to reflect it in the database, you could do it in this way. Basically, we want to do like this. Update database, or actually we can do like this. Before we do this is that we should first do a check that we get what we want, right? Where ID in 3, 6, 7, for example, say that I want to see that I have gotten these correct rows. Let's go in here and see that, let's see, yeah, you can see it doesn't work. That is good that it didn't work. Reference column ID not found in from class. Okay. Yeah, because we need to have from database. Select, I've done it wrong. Okay. Select star. I missed this from. Okay. Yeah, that was good that we did this check. Okay. I copy this one, put it in here, and now it should work. Yes, I get these 3. The idea is that I want to change the learned here, right? Now I do copy this, and to copy quickly, shift option down button, or shift alt down button if you're in Windows. Instead of select now, we will do update database. Actually, we'll update this table, and we do set now. Set learned equals to true, where ID is this. Okay, save this one or copy this one and paste it in here, run it, and you can see that if we now run from database.duckDB, and you can see that, yeah, these 3 have become true because now we have learned them. This was the update. We modify the table. Let's move on to delete here. Note that, okay, alter, create, and drop here, these are DDL, data definition language, while the CRUD operations that we're working on here, these are DML, data, the read is actually DQL. The other ones are DML, data manipulation language, okay? Yes, they are a little bit different. Now we'll go into deleting. Let's say that I want to select star from programming.python, where ID equals 2, for example. I want to check which we have here before I delete it. I add a cell here and I run this one, and you can see, type hint. Actually, I don't want this glossary. I think I've written it wrongly, maybe. Yes. Then I check that which ID I have. Okay. Basically delete, and then we have same as here. I'll copy this one. Okay. Delete from program.python where ID equals 2. If I copy this one, and I will add a new cell here, run it. And you can see that if I do from programming and .python and run this one, and you will see, yes, the ID 2 has disappeared. Okay, great. And also you can do, for example, we want to do, let's just for fun, let's do like this. I'll go up here and I will find the insert, this one. I'll run it again. Okay. Now when I have run it again, let's see what happens when I do from database.duckdb. And you can see, it copied, right? 10 here, or 11, it's same as DuckDB, 12 is same as row 2, etc. Then I want to delete all that are after 10, okay? Then we should select star from database.duckdb where ID is larger than 10 to just check that it will delete what we expect it to delete. I create a cell here in between. You can see yes, from 11 to 20. Perfect. Okay, I copy this one, and instead of select, I do delete here. Delete. Okay, I copy this one, and I can do delete here and run it. And if I do from database.duckdb, yes, it has disappeared. However, now when we we insert a new row, then it will be in ID 21 because the last ID was 20. Just to note that. Okay, this is DML still, CRUD operations. These are the CRUD operations. However, we can drop the tables and schema directly using drop. And this is the DDL, data definition language. Here in drop, let's do this. We can do drop table database.sql. And you can also do like this. If I drop this one, now you can see if I create a new cell and I will do dest, and you can see that glossary only has 2 tables, right? We delete those tables. How about, say, we want to delete a schema containing all the tables? If we just do like this, if I do drop schema, let's say schema programming, see what happens. If I drop this schema, I'll create a cell here. And you can see there's an error, dependency error, cannot drop entry programming because there are entries that depend on it. Table Python depends on schema programming, right? We use drop cascade to drop all dependencies. I could have a lot of tables inside of this programming schema. If I want to delete them all, I do drop schema programming cascade. Then I don't need to go in and drop each table, right? If I just add this cascade here and I run it, and it's fine. If I do desk here, now you can see there's only 4 DuckDB left. What you can do to check this is also like from information schema dot tables, and you can see these are the tables that exist, and you can do from information schema dot schemata to see which schemas there are. Now you can see there's only this database schema and this main schema here, which I don't have anything. Yes. Now remember to commit. Actually, I will close this down, Control C, or Control P actually. And now you can see the connection to DuckDB is lost. And you can see there's still a .val file here, and I'll delete that one, fill in DuckDB, glossary.duckdb. Okay, I'll close this one. There's an error here. Let me debug this. Okay, I'm actually quite glad that I got this error. You might think I'm strange that I'm glad that I got an error or a bug, but this made me understand why I've gotten it now. I'll show you a little bit how I did for debugging. Basically, you saw that I couldn't open my glossary.db, right? There was some strange error. I deleted my .val file to see if I could open it. And when I opened it, we saw that there's no changes, of course, because the write ahead log hasn't been parsed correctly. What I did was I deleted the database and I restarted again. And then what I did was to run through each cell in the notebook to see whenever I get an issue. And what I suspected was when I dropped the tables or when I did alter, I checked for the dropping and I checked for and I saw that, okay, it was actually that was the issue. When I did this code here, table database.duckdb, there is an issue. Because before I did that and I closed down the local UI and then I open up the DuckDB CLI and everything works. But after I did this alter table inside the local UI, I saw that, okay, this error appears. Okay, good. Then I isolated that it's during the alter. Could it be that because I use these strange names, database.duckdb, that when I alter this one, it will make it not possible to parse or some strange thing? Yes, and then I tried to alter the programming.python, that schema and that table, and did the same altering, and yes, it didn't work either. It became the same error when I did it in the local UI. Okay, and then I tried to, okay, how if I don't do it in local UI and do it directly in the CLI? Okay, if you have local UI open and you do it in the CLI, then it won't work. It will be the same error. However, if I open it up in the normal CLI without local UI, like this, duckdb glossary.duckdb, and I do this alter and the error doesn't appear. It seems to be like there seems to be a bug in local UI together with this alter. I'm not sure exactly why, but this is what I have noticed. To work around this, I will show you from start how I will do. I will first close this down. I will remove this one, and now I will do duckdb UI glossary duckdb. And you can see this is the code that we have created. I will run this one, I will run this one, I'll run this one, and here, and here I will do comment this out. This is also dangerous. If you want to use that one, you should also comment it out. And here I will say a note here. Notes. There will be a bug here. Run this in the normal DuckDB CLI and it will work. Okay. What I do here is that I move back to my terminal. I do Control D to close it down, and you can see .val, this doesn't disappear. We'll do duckdb glossary.duckdb, and you can see if I do this, I have my tables, everything works. And I just copy in this code here, copy it in. And now I do this again, and now you can see the learned column is there. And now you can see there's .val file here. If I do Control D, it disappears. Everything works very smoothly in the CLI, but the local UI, there are some bugs. But we will open up the local UI again. And here I will move after here is the alters, right? After that, we'll continue to run it, and everything else will work, I think. Okay, now I have run everything. There should be a run all button. I haven't found it, or they haven't implemented it yet. Now I will just do Control D, and then there's this bug again that the .val file doesn't disappear. What we need to do is to open it up with the normal CLI, and here what you can do is you can see this. everything worked. We have deleted the other ones, right? Because that was what we did in the later stage of the local UI. Now, if I do Control D, you can see .val file disappears and everything works as expected. This is the workaround. You need to run this inside the DuckDB CLI and not inside local. Okay, now make sure to commit and push your changes to GitHub and also write this note about it that you can work with it. Yes. Okay, in this video we have gone through CRUD operations. We started out with some DDL data definition language such as create, alter, and drop, okay? And also we use create, read, update, delete, using insert, read using select, and also where clause, and update using update, and delete using delete. And then we found out there was a bug in the local UI with the alter statement. What we did was the workaround was to run it in the CLI in DuckDB, and afterwards go back to the local UI. I hope that you learned a lot in this video and that you get more and more familiar with DuckDB and its power. This is super fun, and I hope that I will see you in the next video where we'll go into grouping of data. That would be fun. Okay, see you then. Bye.